Hi, my name is John Liu, and welcome to my channel. On this channel, I plan on doing contest math. As the name implies, that is math from math contests. I plan on uploading 1 to 2 videos a week, each video about multiple math problems, all tied together by a single theme. The first thing I want to do is to demonstrate how seemingly challenging and difficult problems are actually not as hard as they seem. So, this is a problem from the 2014 AIME. The first thing you might notice here is that there's a power with the cosine of pi x. So we're going to look at different values of x to see what cosine of pi x is. So x cosine of pi x. If x is equal to 1, then the cosine of pi x is equal to negative 1. If x is equal to 2, then the cosine of pi x is equal to 1, because the cosine of 2x is equal to 1. If x is equal to 3, then it's negative 1. If x is equal to 4, then it's 1, so on. We begin to notice a pattern here. If x is odd, then the cosine of pi x is negative 1. If x is even, then the cosine of pi x is positive 1. We then turn our eyes to the equation below. So if we have the absolute value of a sum of the log of f of k, and this is all equal to 1, we can instantly change this to the sum of the log of f of k is equal to plus or minus 1. Why? Because if you take out the absolute value, the other side becomes plus or minus. Now, if you know your log rules right, you will know that the sum of two logs is equal to the product of their interiors. So this turns into log of the product of f of k is equal to plus or minus 1. Or I'm actually going to rewrite this as 1 or negative 1. So then we take both sides to the power of 10. So this becomes the product of f of k is equal to either 10 or 1 over 10. Now, we go back to here. Consider the first few values of f of k. Let k be equal to 1. So we have it that k squared plus 3k plus 2 to the power of cosine of pi k. Okay? Let k be equal to 1. So first thing we can do is factor this as k plus 1, k plus 2, all to the power of cosine of pi k. This is really important because we are going to do something called a telescoping series. Let k be equal to 1. Then we have 2 times 3 to the power of negative 1 gives us 1 over 2 times 1 over 3. Now see what happens when k is equal to 2. Then we get 3 times 4 to the power of 1. So we have times 3 times 4. Alright, now see what happens for other values of k. For k is equal to 3, we will get 1 over 4 times 1 over 5. And then for k equals 4, we will get 5 times 6. And so on. But one thing you might notice is that these cancel out, these cancel out, these cancel out. So eventually, we will only have 1 over 2 times the last term. So then we keep on doing this until we eventually get answers of k equals 3 and k equals 18 to be our solutions. Sum these up and our answer is 21. Or on AIME, you would write 0, 2, 1. And that is your answer. This question was actually quite straightforward. It just involved some basic knowledge of all of these concepts to make a pretty simple solution. So yeah, that is what you can expect on this channel. Thanks for watching, and see you next time, hopefully.